Hello and welcome to the second episode of Deconstructing Contoso Real Estate. For those that join us for the first time, Contoso Real Estate is our reference architecture and open source application implementation sample for enterprise JavaScript developers on Azure. I got all messed up because I was laughing at our trooper, and I'm going to invite our trooper to introduce herself. We have here Glaucia, or the
Hello.
trooper.
Yeah, totally. Yes. Hello, everyone, in different places in this beautiful planet called Earth. My name is Glaucia Lemos. I'm based in Brazil, Rio de Janeiro specifically. Welcome to this Learn Live session.
Yeah, thank you, Glaucia. And we also have Brian.
Hello, everyone. I'm Brian. I work on a language called TypeSpec, and I'm excited to share that with you.
Super excited also to have Brian tell us all about TypeSpec. And I'm Natalia, and I work with the end-to-end team leading the developer experience for JavaScript developers on Azure. So before we start, we are going to welcome our moderator, Dina Berry. She writes a lot of the JavaScript content that you'll find in the Microsoft Docs, and is here to help us moderate this session and answer questions as we go. Thank you, Dina, for doing this important job for this session to succeed. Don't let Dina get bored. Say hi, tell us where you're joining from, and ask us questions. We are here to help you and to interact with you, and hopefully we can have a nice conversation during this stream. So let's go and see what we're going to learn. In lesson 2, which is this one, we will unpack the front-end components of the application. You'll learn what API first design means for composability and how to use best-in-class tools from our ecosystem to design API specifications that result in quality and compliant API shapes. You'll also learn what micro-frontends mean in the context of composability and in the context of Contoso. And you'll learn what serverless means for composability and how to leverage the recently released programming model version 4 for Azure Functions to benefit from the newest capabilities of the Node.js runtime and JavaScript APIs that you have available when you're running on that version. So with that said, let's see what the session 3 has for you in store. In lesson number 3, we will unpack the backend integrations. You'll learn what authentication means and how it enforces route access. You'll learn to integrate payments and see how API-first design helps with that. You'll learn to work with different data stores and understand the implications of it. And you'll see how authentication is implemented in the portal. You'll see how payments are implemented with a third-party API. And you'll learn how Azure Cosmos DB, Azure PostgreSQL, Blob Storage, and the CMS that are part of the application work. And that will set you up nicely for session 4. In session 4, we will get ready to deliver our application to production. You'll learn how infrastructure as code makes deployments consistent. You'll learn how Azure Developer CLI, our tool for provisioning and deployment, makes those processes effortless. And you'll learn how Playwright makes end-to-end testing and automation reliable. So you'll basically learn what an ACD template looks like and how to deploy to Azure using them. You'll learn what a Playwright test specification looks like and how to time travel. Wow, you'll have troopers and time travel. And you'll learn how github-copilot can help author, explain, and refactor your code. So don't forget to register for the whole series. But before we get started with this lesson number 2, let's talk briefly about where you can find all this information in one place. Let's say hello to Fall for Intelligent Apps. This is a fantastic initiative we're supporting with our friends in the Cloud Native Advocacy. the marketing and product teams. And the goal is to help you explore cloud scale data, cloud native applications, and cloud integrated artificial intelligence to create the next generation of user experiences on Azure. So check it out at https://ms/fall4ia as intelligent apps, and then click the Learn Live button to see links for all episodes. And please register so we have you here with us learning more. Now, remember, our Contoso real estate application and reference implementation represents a development environment, and as such is always under active development, and it may be unstable at times, since our goal is always to integrate new service features and new capabilities as we go. So deconstructing it, or what we're doing today here and what we're doing throughout this series, is about the real-world experience of working in a multi-team, large-scale code bases that deliver or are always on fast-moving deliverables. And if you come across bugs or issues, we'd love for you to join us, and we'd love to see your contributions, your pull requests popping up in GitHub. And what are our learning objectives today, concretely? So at the end of the first part, because we have two parts for this episode, so at the end of the first part of the session, you'll have a good understanding of how API-first models help building better software, or better web software in this case, and what tools you can use to describe API shapes. So without further delays, let's get into the gist of it. This episode is all about APIs and API first. And what is API first? This is what you may be wondering at this point, if you never heard about it. It's a development approach where the design and development of the public interfaces that connect the backend and the frontend, what we know as APIs, is prioritized. This approach emphasizes creating a well-defined and robust API layer that exposes the application core functionality and data to clients. What are those clients? Well, it can be web browsers, it can be mobile applications, it can be other services. And using this model, the API layer becomes the central connecting tissue between, again, clients and servers, and the front end and the back end. You can also think about it this way. And they can be developed independently, allowing for flexibility and concurrency. So some of the proponents promote a flow that starts with developers designing the API endpoints before anything else. However, I personally feel more inclined to promote a pattern that starts with the UI design. Imagine the designs in Figma or in any other tool that you use to create precisely graphics. And then those designs that are based on user stories that business analysis will deliver, of course. From there, we can already proceed to design our API specification. So what is an API specification? Typically, developers and architects will use tools like OpenAPI or Swagger to do that. It's just a description in human readable language of how things connect and what they do. So when we design an API-first system, we have a set of non-functional advantages as the objective to enhance reliability, scalability, security, and maintenance of web applications. So basically, this is what we try to do when we introduce a model like the API first. What makes it possible to achieve these optimizations is that an API-first approach enables decoupling of the different parts of the application, as we mentioned before, and particularly a separation of concerns between the business logic or the data processing or the data access and the front-end or user interface. And we can then compose it back or put those parts back together in a loosely coupled way. If we think about monolithic systems, for example, that do not implement an API-first system or model, they are tightly coupled. Everything is very interdependent, very intertwined. If you make changes to one part of the application, you're probably going to be affecting other parts, sometimes without even knowing or having a good overview of what exactly you will be, what changes you will be introducing as a cascade from one part or component to another. But when we are working in this, with this type of approach, and we put those parts back together, deploying and running them on different services that we may be choosing using a decision matrix, for example, to evaluate what is the most efficient service to deploy one part of the application or to consume data from. We can also subtract, we can add parts, modify parts, all in a very independent way. And we can choose our stack and architecture with less constraints because we are not really limited by what other parts of the application that are, again, loosely coupled may need. We can think about our specific business or use case and try to satisfy it, making independent decisions from other teams that are working on other components. So the API-first approach promotes a modular and efficient way of building and maintaining the backend, which in turn positively impacts the overall performance and functionality of the application entirely. And it results in systems that are more scalable, that are more secure, that are more performant. In the end, an API-first approach contributes to the overall maintainability, robustness, and compliance of software systems. Yeah, that's already a lot of information. I don't know if we have comments already from the audience. Remember that you can talk to Dina, who is moderating. You can send her your questions so she makes it available to us, and we can also have a nice conversation. So additionally, incorporating an API-first approach promotes, as you can see, clear communication among independent development teams. We were talking about teams that make their own decisions, that are less constrained, that have more freedom, that can think about, okay, what are the skills we have in these cross-functional teams, and how can we better deliver our component? We can have our own development cycle. We can have our own release cycle. So these teams become really autonomous, and that requires, of course, that there is a layer of governance, that there is good documentation. So in the end, adopting this type of model enhances code quality because we're going to be paying more attention of how we communicate to other teams, how we document our code. And we're going to be needing something that is known as contracts to make sure that everyone is on the same page, that we are observing some conventions, that we are delivering a consistent and coherent and consolidated system in the end that we can, again, couple back or put back together. And that leads, of course, to overall efficiency. And yeah, Contoso Real Estate was designed as an API-first system, meaning that we went from use cases to user interface design, as I mentioned earlier. We went from the Figma mocks to then having an API specification. Then the front end and the backend development were done concurrently. Please follow the link or the QR code and fork our open source repository. You can build it, you can start contributing, you can start applying everything you're learning in this series. And if you love it, give us a star too. So that approach that we followed, the API first approach, allowed us to design scenarios as building blocks that you can see here that satisfied a specific user story and business case in isolation, and then use them to compose, again, a consolidated large-scale application. What you're seeing here is the scenarios 1 and 2 that are connected through the serverless API layer that Glaucia is going to be speaking about in the second part of this episode. You can see the scenarios that we will explore today in the diagram. And also you can see the services that map to the different application layers there on the bottom right of the slide. And the services, again, that map to each one of the components that are either hosting our frontend, data access and compute, and data storage. Now let's dive deeper into these two first scenarios. The scenario 1 is a dependency to all other scenarios. It's a foundational block, let's say, to it. And the following Azure services support this headless content management system deployed to the cloud scenario. Azure Container Apps to host the CMS or content management system and the backend server that runs it, the content management system administration app, and the blog application. Since it was all considered part of the same scenario, and we needed both hosting and scalable compute on demand, meaning we may have spikes of traffic that we want to serve, or we may not have any traffic at all, so we may want to scale down to 0. So we decided to go with container apps. That also allowed us to put everything together, the server and the application in the same container, both in the development environment and in the cloud. Now, we also needed a service to store unstructured data, like binary files, and PostgreSQL was used for the structured data. So the binary files were, or for the binary files, we selected the blob storage, Azure Blob Storage, and for structured data, we selected PostgreSQL or Azure Database for PostgreSQL. We wanted to have examples of both SQL and non-SQL queries represented in the scenarios in the application. And for this type of data, we decided to go with PostgreSQL because it's one of the favorite databases by JavaScript developers, and we know that many people in our community use this technology, and we wanted to give it representation in the scenarios. Now, when it comes to the technical stack, let me get there. We have Strapi, we have, again, PostgreSQL, we have Next.js, and we have Docker. You may be wondering why Strapi, right? Because there are many options for content management systems and headless management systems. But remember that this is an open source reference, so we wanted to stick to open source technologies. But also, as opposed to other options, which don't offer this capability, let's say, Strapi can be deployed to the cloud and also run locally in a developer computer or environment. That doesn't mean that the sample cannot be modified to work with other content management systems, those that run in the cloud exclusively. Everything is possible. It just means that for this particular scenario development, we decided to go with Strapi to show all these possibilities. And again, PostgreSQL, because as I mentioned before, we wanted to have a reference of SQL querying directly from the two front-end applications and going through this API layer that we're going to talk about later. Now, Next.js is a very popular front-end framework. We wanted to showcase its server-side rendering capabilities and how they run on Azure, and the optimization of runtime performance these type of mechanisms provide. And when we take a look at the code base, we can see that we are using NPM workspaces as a way to structure our code and do our dependency management or perform our dependency management strategy. And as a standard convention, when you are implementing workspaces in NPM, you will have the root of your project, you will have the package.json, the manifest, and you will find a folder typically called packages. Instead of having the source of the application directly at the root, and it's just one, we're talking about a monorepo kind of structure. So we will find this packages folder, can be renamed, reconfigured, but we went with the default. And each one of those packages that are inside of the packages folder will be an NPM package in and out of itself, right? And have its own package.json, declaring dependencies, scripts, entry points, whatever you typically have in your package.json. However, when you run NPM install at the root of a project that features workspaces, all dependencies will be installed in a single node modules location. Of course, you can change this strategy as well. This is how it happens by default. There are different installing strategies. And you can see the link if the banner is running to the documentation of NPM workspaces. Now, again, using this monorepo strategy makes it simpler when you have a large-scale application and when you have different scenarios that you want to compose together and that you want to work, but you want to work independently, although they may share certain dependencies, to do it in this way. And so, for example, in the case of how we are optimizing our development environment to work in code spaces, this is a real benefit, right? Because again, we can have a repeatable, let's say, server installation everywhere in the development environment and in the cloud inside of a container that is pre-configured and predefined. And we just put it from the developer environment to the cloud in exactly the same way. That means that it's completely repeatable and consistent across the many development environments and even testing environment, production, whatnot. So if you want to know more about code spaces and dev containers in general and how they relate to Contoso real estate application, you can watch the episode 1 with Nitya. She went in a deep dive, or she did a great job exploring all the possibilities of code spaces and how NPM workspaces work inside of the code spaces, forward imports, starting several servers and connecting all the pieces together. Now, we have a better understanding of the monorepo structure that makes it possible to have these independent scenarios working together in composition, and how dependencies are fetched from the package manager and installed at root level. And we can verify that in this case, this is a screenshot of the code base, that we have the packages folder that is including a packages/blog-cms as one of them. And when we run npm install at the root, again, we will have the blog-cms dependencies installed for the Strapi CMS server, for the Strapi administration panel, for the Next.js application that the blog is built with. Everything will be built directly from the root. The scenario 2, however, represents the portal application. So this is a real estate portal that has a blog and has then the portal where the users can go and see all their listings. We explained the whole architecture in the episode 1. I again invite you to go and take a look so you have a better understanding of how the application is built. But from a start perspective, in this case, the scenario 2 is a much simpler build than the scenario 1 that we explained before. It is, again, it is a real estate portal deployed as a static application, and it's built entirely with Angular. So it's a much simpler build, but it doesn't mean that it's not quite sophisticated. We are introducing the latest version of Angular. We're introducing goodies like signals and standalone components, and all this is nicely built, again, from one command at the root level. It's a portal. So what does it mean? We're going to have some listings being shown there. We're going to have a list of them, and we're also going to have details from them. Again, I invite you to go back to the episode 1 to see exactly what the application looks like. And how do we create that data? Do you remember that we were mentioning that we had a content management system in the scenario 1 that was basically the foundational block, and that every other scenario was going to be somewhat dependent on it? Why? Because they're going to be getting the data that is authored through this content management system. That's why we have the server, and it's going to be as well stored in that PostgreSQL database that we mentioned with the images in the blob storage. So we have these two independent scenarios, yet they are interconnected. We will configure the Strapi CMS to be able to create a data type called listings from the same authoring interface that creates the blog posts. So authors have a centralized system to manage all content. That means that we will need to create a connection between the portal application that we just mentioned, built with Angular, to query all those listings so they can be shown in the application, to query each listing individually as well, so we show a listing detail, and also to run the search capability. We are not going to be creating the listings themselves from the portal application. We are always going to be authoring from the content management system. It's important to remember that up to this point, there are still no users in the application. So that is a scenario number 3, where we add authentication, and that's going to be described and explained in the next session in episode 3. But we're still able to, as anonymous users, to see all this content in the portal. And when we have authentication, by the way, we are going to be able to add additional functionality, additional capabilities to the portal, like, for example, payments and favorites. And all this will also need what we are going to describe today, an API. This is exactly how we create the connection between one application deployed to the container apps, or to Azure Container Apps, the CMS, and the portal deployed to static web apps, so we can fetch the listings. And yes, for these internal capabilities of the blog, we are not going to be needing these serverless functions that we're going to be building the API with, that Glaucia is going to show you in a few moments, because it uses some internal mechanisms and plugins in order to fetch the content. But when we are in the portal, we will need definitely this compute, this connecting tissue, as I mentioned before, this API layer, in order to communicate from one application to the other, to fetch data and to get it back. When we are in static web apps, like we are with the portal, we have several options to create APIs. We either use their built-in capability, so they have a capability to create APIs, and yeah, the function, the endpoints are automatically fetched. They are configured, and the mechanisms that make it possible not to have that enable cores, are automatically handled by the application internals or by the service internals. You don't have to deal with any of that. So basically, you just use the API inbuilt capability, and you're going to have a lot of those configurations already solved or managed by us, by Azure. We use their recently released data API builder that allows to declaratively configure endpoints, to configure schemas, to configure permissions, to quickly build APIs and dynamic applications at scale. That would be the second option. Or the third option, like in our case, we can use the bring your own backend capability to manually link endpoints to the static application. This allows us to have more fine-grained control and a broader range of integrations, including, for example, API management and private VNets. So how do we create those manual links? We can do that from the portal, from the Azure portal. We can do that with infrastructure as code. We can do that with the static the Azure Static Web Apps CLI, sorry. That will be explained in depth in the next episode when Johan is going to be building that together with you. But for now, what we're going to continue to talk about is, okay, now we have these packages. We already showed that we have the packages /blog CMS. We also have a packages/portal where the portal application, the Angular application lives. We will have the API folder inside of the packages as well. As we mentioned, everything can be installed. All the dependencies for all these packages can be installed directly at the root when we are in this workspace scheme. But yeah, that's how the application works. But still, we mentioned earlier that we needed some way to explain one application, how it's going to be fetching the data, that we need some sort of documentation, that we need an API contract. Again, we are imagining that each one of these applications is being built, is being developed by independent teams that maybe are not chatting to one another, but they probably need some way to understand how they're going to query the data, how they're going to be fetching the data that is managed in a system that is built by another team. How do we do that? And this is exactly what we are going to be discussing with Brian, that is going to be joining us in a moment. After building our Angular application and writing our functions that we have developed independently and having everything packaged nicely together from a front-end perspective, we have now 3 micro-frontends or 3 micro-frontend splits, 2 of which are end user-facing and accessible from the internet, and another one that is also accessible from the internet, but maybe behind some authentication wall. That is the Strapi administration application. Each one of those applications, again, are accessible from different URLs. We can assume it's like if we have a top-level domain, XYZ, that we have blog.xyz.com, portal.xyz.com, and admin.xyz.com. Because in this case, each one of those front-end applications in our fictitious use case are meant to be developed by independent teams as independent packages with independently chosen technologies and technology stacks, and have their own development and release cycles. We can think of them as, again, vertical micro-frontend splits in the context of a micro-frontend architecture strategy. And they, again, do connect to the same backend database through a unified and consolidated API layer that provides a contract, conventions, and governance. And it looks super easy peasy to do. But if you've ever seen an API specification, you'll see that there is a lot of code to write, or a lot of configurations to make, rather say. And for sure, there are challenges. And again, we have Brian here to tell us all about the challenges we may be facing when designing API-first systems and how to overcome them. So Brian, the mic is yours.
All right. Yeah, so API first design comes with a lot of challenges. And at Microsoft, we actually struggle with a lot of these as well. So let me just go over some of the challenges that we've seen out there. One is designing APIs at scale. The larger your API gets, the harder it is to have a consistent API, and maintaining consistency and quality becomes very costly. A lot of organizations have API guidelines, but these guidelines are difficult to apply to, you have a PR coming in and you have to look through all your guidelines to see, what things are okay and what aren't. And often that review comes too late in the process, so that introduces some cost and some rework. Likewise, as your API evolves over time, versioning becomes very difficult. For a lot of services have contracts with their users that they can't break them, but they still want to evolve those APIs, and doing this is often a challenge. Service implementations are part of this challenge as well. If you're handwriting your service, it's really easy for your service not to sync up with your API spec. And that creates a lot of confusion, and in some cases, some really bad bugs for users. Similarly, our users really want high quality client libraries. Oftentimes this means writing them by hand, but at a certain scale, this is impossible. Like, you just can't spend all of this time writing client libraries. So you have to generate them. But if you've used any API based client generation tools, you may have noticed that they don't feel like they're handwritten, and it would be nice if they were. And related to OpenAPI in particular, it's a great tool, but I think it's fair to say that the authoring experience is not as good as we would like. You can kind of make it nicer by using some tooling, but it's YAML or JSON based, and is often difficult to write. And also, applications today are highly polyglot. Like, we're using multiple different protocols, multiple different services that speak multiple different serialization formats. We have the same sort of type represented potentially in a bunch of different places, whether it's the database, whether it's multiple different protocols, your event bus, et cetera, et cetera, et cetera. And this creates a source of truth problem that is very difficult to handle, especially for larger applications. So you can go on to the next slide here. So what we need is a way to codify our API guidelines into reusable components. So when you're developing an API, you get consistency and guideline conformance for free. And in fact, it's the easiest thing to do. Just use the existing component that does the thing that you want. Don't write it from scratch. And it's easier and better. We want to describe operations and their associated shapes. We want to drastically improve the developer experience. API first is great, but it's not going to feel good unless the tooling is good. And so we need a way to make that experience of doing API first productive and ultimately fun. We need to support a wide range of protocols and serialization formats. And we need to drive high quality assets, the generation of high quality assets. And this is not just clients, but also servers, docs, CLIs, database schemas, migrations, other API specification formats, all of that. So that is what led us to build this language called TypeSpec. It's a protocol agnostic language for building APIs and API service descriptions at scale with the help of a tool that makes high quality, consistent, and idiomatic APIs in client generation and service generation, and all of that, a great experience. So here's a quick demo video that should explain the basics in just a few minutes. TypeSpec is a new programming language from Microsoft designed to build API descriptions at scale. TypeSpec provides a simple, terse, highly expressive, extensible core language to describe any API and supports compiling into industry standard specifications like OpenAPI, JSON schema, or protobuf, and can be configured to generate any other asset, whether standard or specific to your business. TypeSpec is designed to address problems faced by Azure. Azure has hundreds of services with tens of thousands of endpoints, thousands of API guidelines, and a very high quality bar for service implementations, clients across a number of languages, documentation, and other artifacts. Building everything by hand at this scale is impossible. Tools like OpenAPI help, but leave a lot of problems unsolved. If you're building an API, TypeSpec will help you ship faster while improving API quality and consistency. To get started, install TypeSpec using npm. Next, use TSP init to create a new project and select OpenAPI 3 to emit your API into standard OpenAPI. Lastly, type TSP install to get the necessary dependencies, and you're ready to start building. Define your API's data shapes and operations using features that borrow heavily from other object-oriented languages like TypeScript and C#. Use TSP files and namespaces to organize your code. Model, enum, and union to define your API's data shapes, and interfaces and operations to define your service's operations. Use decorators to define the protocol-specific behavior of your API and add other metadata. TypeSpec's language service has features programmers expect, like IntelliSense and refactorings, that make API development very productive. From here, make use of TypeSpec's rich templating and composition features to abstract common API patterns into reusable components. These components can encode your organization's API guidelines and best practices and can be packaged into libraries for distribution across your organization or even the broader ecosystem. These features are available for any output format, including standard OpenAPI. We can still make use of OpenAPI tools like the Spectral Linter or Swagger UI. We can even take our existing API description and emit its data types as JSON schema, or add metadata for protobuf and emit the same service to OpenAPI and protobuf at the same time. TypeSpec has many features that make building APIs and their surrounding ecosystem far less challenging at scale. Build custom linters to warn developers about questionable API choices at design time. Build custom type and decorator vocabularies to describe APIs in terms of your business's needs rather than low-level protocol details. Build emitters to produce custom artifacts like highly tailored service or client code, documentation, database schemas, or other API description formats. TypeSpec is open source and available today in pre-beta. Visit our website and GitHub to learn more. All right, so let's take a look at what TypeSpec brings to the table. A lot of this was covered in the video, but I just want to go over some of the highlights. First of all, the syntax should feel very familiar if you've programmed in TypeSpec or C# or Java or really any object-oriented language. The core of the language is super simple. There's not much to learn. So you should be able to pick it up quickly, certainly be able to read it without too much effort. One of the most useful aspects about TypeSpec, I think, is this ability to create these Lego bricks, these reusable components that encapsulate high-level API patterns so that you can reuse them across your team or your organization, or even put them on NPM and share them with the larger community. In Azure, we actually have created our own set of Lego bricks for building Azure services. And one of the really nice aspects about this is certain services are highly regular. And so we actually don't need to even talk about individual operations a lot of the time. We can basically say, hey, here's my resource type, and I want an API for this resource type. And that will go off and generate the oftentimes thousands of lines of open API from maybe 100 lines of TypeSpec. It's excellent. Great tooling. The language service offers completions, go to definition, symbol explorer, refactoring, like you can just rename something and it'll rename it everywhere. There's a lot of really great stuff in there that makes building APIs super productive. It's also extensible, especially combined with the custom emitters that you can build. TypeSpec lets you define your own metadata, which lets you describe business constraints or other protocols or basically anything that you can augment your API shapes with this additional metadata that can drive the generation of higher quality assets. So an example, again, from Azure is we use this extensible metadata to describe, for example, how clients should look in certain cases. So we can go into the spec and we can say, hey, the client should generate this sort of pattern for this endpoint. And that lets us, is one of the ways that TypeSpec helps us get handwritten quality clients out of our code generator. It's highly expressive. So even if you're just writing low-level HTTP, you're looking at maybe a 50% or more reduction in the amount of lines of code. Oftentimes, especially if you're using Lego bricks, this can be, your type specs can be much, much, much smaller. And you sort of get all of this with your existing tool chains. Like if you're already using OpenAPI, great. We produce awesome OpenAPI. We are committed to interoperability with the existing standards. We're not trying to at all replace any of these existing ecosystems. We're trying to work together to build this awesome API first world. So there's a playground that you can go to if you want to try TypeSpec in the browser. There's a sample drop down in the top left if you want to explore some various samples, and you can sort of see the output update as you type, which I think is a really great way to explore. And go to the next slide. Yeah, so I think this link was shared earlier, but you can go to aka.ms/try-typespec and learn more.
Absolutely. So let's see if I learned this, if I got this right. Brian, if I learned from the video that we just showed, I have TypeSpec installed globally in my system. We can see that because I type TSP help and I get all these commands, this help from the CLI. Obviously, like Brian said, it's great to have tools, but the developer experience of those tools has to match the expectation, and it definitely does for me with TypeSpec. So let's start a project and see how easy it is. I'm going to just go with TSP init as it was instructed in the video. I'm going to select a generic REST API, and then, yeah, let's do this Contoso try. And I'm going to select TypeSpec / OpenAPI 3, right, Brian? That's what we want to do for Contoso. And now that we have initialized our project, we get this main.tsp for free. Of course, it doesn't. Yeah.
You need to share your screen.
Oh, wow! It's not sharing. Okay. So I'm gonna have maybe to start again. I didn't realize that it wasn't sharing. Okay. Folks, you should have told me earlier. I thought that I was on the full screen, but I wasn't for the video. Okay. You weren't paying attention. Okay. My computer. It's okay. We'll do it again. Share screen. Okay. I am now, right? So, can you hear me? Yes. Can you hear me and see the code? Okay. So what I did is basically in the interest of time, let's go quickly over that. I had an empty folder. I just ran TSP help to make sure that I had the TypeSpec installed globally in my system. Then I went and did TSP init. It prompted me to select a template. I went with generic REST API. Then it asked me to select a project name or to give a project name, or it also provided a default. And then it asked me to select the libraries or the library that I wanted to use. I went with @TypeSpec /OpenAPI 3, and that's what I had done when we were not sharing. Now that I after right away after doing this initialization of the project, I get this main.tsp for free with some imports already. Of course, it doesn't find them because I haven't yet installed them, and a package.json manifest, which is just a regular package.json. So now we're going to do the TSP install. This will install all the dependencies. Let's hope that it's quick because my internet is not really helpful today. But again, what it's doing is it's installing all these packages so I can then import them. There we go, completed. There you go. So it still doesn't find them. Let's just close it and reopen, and then they should be there. And what I'm going to do right now is I'm going to write something that could look like the Contoso real estate application specification. We already have an OpenAPI.yaml in the project that you can go and take a look at. But let's quickly see how I would write it with TypeSpec. What I like the most about this tool is, of course, I am a JavaScript, I'm a TypeScript developer, and for me, it's very intuitive. From the first time I came across this tool, I really loved that I could understand, like Brian said, what the code was about, and I didn't have to go through some very deep learning curve in order to understand it. So what we're going to do is I'm going to start writing it, and you can also see the language service. So we're going to be using TypeSpec. It gives me this, I don't know why it gives me this TypeSpec. I don't know why it doesn't find it. Oh, because it has a typo. Okay, so TypeSpec, and now we're going to add a service. And you can see that it's giving me all these options. Let's see, a service, and we're going to call it, let's see, I want to do it correctly. So this is an object, and we're going to pass a title, and my title is, okay, this is my Contoso API, and we're also going to give it a version because that's very helpful for developers, right? So let's say that this is a 1, and then I'm also going to declare a server. In this case, it also tells me, okay, what do you want to tell about your server? Let's see, it runs in /API. This is what in static web apps, the default folder for APIs. And I'm also going to pass a description so I understand which API is this one. Say Contoso real estate listings API. And why it doesn't like it? Maybe you see, Brian, do you see the issue here? Do we have Brian still in the call? Hello?
Sorry, I was trying to talk using text. Just put your namespace.
Just put what?
Put the namespace underneath the.
Oh, the namespace. Okay, so it's asking me for a namespace, and we are going to call it Contoso real estate. Okay. All right. So now we have the service, the server, and we should have a lot of models declared in order. What we're going to do is just to write the specification for the listings, to fetch them, to get the listings and the one listing with the ID. And I'm going to, for the sake of brevity, I'm going to be copying and pasting this directly from my repo that we have as an example. That is also going to be probably linked. Let me get to the code. And wow, because I have made my my font so large I couldn't find it. Okay, so let me copy all this and let's paste it here.
Don't forget this line 11.
Yeah. So there we go. We have an enum for amenity that is describing a lot of possibilities for amenities. And then we have the address. We need to make sure that we have a valid address, and everything can be described over here as a comment. And we also have the listing model. That's our most important one. We need a unique ID. And we also need to add a created at property. Tell me about this UTC date and time type that is supported here.
You've asked about dates. So do you want the short answer, the medium answer, or the novel?
Let's go with the novel. Yeah.
No, okay. All right. Well, this stream is now going to be 5 hours long. The short answer is, you know how there's the advice that you should always use UTC dates on your service, and you know, clients can convert where necessary. We have a special type of that. It's called UTC date time. It only accepts UTC dates. We also have offset date time if you want to persist offsets, and we'll add zone date time as well if you want to persist time zones.
Amazing. So you have it all. You have us covered, right? And now, UTC. Yeah, I'm gonna go with UTC, and now I'm going to also add an error because, yeah, that can happen. What about the tags? Tell us about the tags.
Tags are an open API convention. So this decorator comes from our open API library, which is maybe not actually imported at the top. I suspect that's the error that it's complaining about. But tags just to organize your API listing, so you can filter by tag and that kind of thing. It helps you find types.
Okay, and now we're going to finally create our route that is going to be listings, and it has to obviously match the one in the Azure function. And we're going to create an interface that is going to be listing. And we're going to use this decorator get, which maps to the get verb, I guess, from HTTP. And we're going to say, okay, we're going to get a list of listing or an error. And for the listing detail, we're going to get a, what is this read, Brian? Why read instead of get in this case?
Oh yeah, so this is it's kind of up to you, but generally speaking, these names are reflected in any code or other assets that you generate. So for example, if you generate a client for this endpoint, the method would be called read. So it's kind of similar to
Okay.
operation ID in OpenAPI.
And now by calling this listen ID, we make sure that we are referring to this uniquely generated ID, right?
Yeah, that does two things. It lets us know that there's a relationship there, which we can use to emit better code. And also, if you change ID ever, then this endpoint changes as well.
I also really like this about TypeSpec, that you can format. Let's say main TSP. And if you, for some reason, are not formatting your code correctly, you can just make sure with this. I think there is another one that it just checks it but doesn't reformat. It's TSP format -- check. And now that we have it and that is checked and we know that it's correctly formatted, we can remove this because we're not using it. We can already compile was that? Oh, no, we were using it. Sorry, my bad. Okay. So server comes from REST. Now let's do TSP compile. This will compile the code, but not really emit a specification. If we want to emit the specification, what we're going to do is compile, TSP compile emit. And then we have to pass the Open API 3, the format. And that was not correct. Emit TypeSpec Open API 3.
Let's see.
Oh, because I didn't pass the path. So it's yeah, I messed it. Let's go back. So I didn't pass the path here. So the command expects the path, and I didn't pass it. Now we have over here the TSP-output that has generated an OpenAPI.yaml for us. So we don't have to write all this, obviously, by hand. It's a lot to write. And like Brian said before, we can have thousands of lines of specification written with a few lines of TypeSpec. And this is it for now. I think that we are over time and we want to have Glaucia have plenty of time to do her part. So thank you very much, Brian, for joining us and for presenting this amazing tool for to help us with API first design and also with specifications of APIs.
Thanks for having me.
Thank you. You're welcome. Glaucia, the stage is yours.
Wow, I'm completely in love with TypeSpec. Probably finally from today, I'm going to use it and advocate for it. Congratulations, Brian Terson, for your demonstration, and Natalia, incredible demonstration too. So congratulations.
Thank you.
Thank you so much.
So hello everyone, thank you for staying a little bit longer in this long live session. So right now we'll be talking a little bit more about the experience that the JavaScript developers team had in migrating to the Azure Functions v4 programming module for Node.js, because until now the Contoso project's API was based on the v3 programming module. Again, my name is Glaucia Lemos. I'm based in the South America, in this beautiful planet called Earth. I'm developer advocate here at Microsoft in the JavaScript team. So let's get started. So there are some prerequisites specifically for the demonstration part of the migration. These include probably, I don't know if you have a time to do the total demonstration, the hands and dirty my hands in the code stuff, but probably I'll be sharing with all of you my intentions to do how to do this migration. But if you want to do this migration in your local machinery or even using your code spaces, definitely you have to use Visual Studio Code or even code spaces and have also a GitHub account, because probably I'll be showing you how powerful it is to use github-copilot to teach us and doing some pair programming with us, or even explaining some a little stuff under the code. And also Azure Functions extension. Even so, if you want to use Azure Functions, has a free tier. So I think that you can use 1 million requests monthly for free. So don't hesitate to test it out using Azure Functions in your projects. So, well, let's see what I will cover during this part of the live session. So there's three main questions that I'll be answering during this part of the live session. So what is Serverless API? How do I migrate a V3 model to V4? And why should I migrate from V3 model to V4? So here is the first question. What is Serverless API? So Serverless API, also known as a serverless backend or serverless architecture. So it's approach to building and deploying web services or APIs without the need to manage traditional server infrastructure. So in the Serverless API, the cloud provider, or in our case, we are going to talk about Azure Functions from Microsoft, takes care of the underlying server management, scaling, and maintenance tasks, allowing developers to just only focus what is most important, just only coding stuff and trying to see the features that the customers needs to the application. But there's some key characteristics of our serverless APIs, which includes, for example, no server management. So with serverless, you don't need to provision or manage servers. So the cloud provider automatically handles server provisioning, scaling, and maintenance. Event-driven, so serverless APIs are often event-driven, so meaning they respond to specific events or triggers, such as HTTP triggers or requests, database changes, or timer events. For me, this is the main characteristics of using a serverless API. The thing related about pay-as-you-go pricing. So you are billed based on the actual usage of resources and execution time, rather than paying for a pre-allocated server capacity. So the team of the developers then can lead to cost savings for applications with available workloads. We know that after the pandemic situation, the world is facing a huge high inflation. So this is a good idea to cost savings for your application to pay as you go pricing. And also our scaling, because serverless platforms can automatically scale your API to accommodate changes in your traffic, ensuring that your application can handle increased loading without a manual intervention. So imagining a Sunday, you are on the beach trying to take some sun, appreciating some vacation with your family, and suddenly you have some situation in the application and family, sorry, I have to go, I have to move out to do some work stuff, and I have to manually outscaling my application. Please don't do that. Please don't do that. So you can do Azure Functions to do, or even a serverless API to auto-scaling your application automatically. All this stuff is stateless. So serverless functions are typically designed to be stateless. So what it means this? So meaning they don't maintain persistent server-side state between invocations. So instead, they rely on external data stores or services for state management. And short-lived functions. Serverless functions are designed to execute quickly and then terminate often with a maximum execution time limit imposed by the platform. So I'm summarizing everything that I talk about what serverless API is. So are well suited for wide range of applications, including microservices, real-time data processing, web and mobile backends, and more, thanks to their flexibility, scalability, and cost effectiveness. So now that we've understood what a serverless API is, so let's explore why we should migrate from the v3 to v4 of the Node.js programming model. So firstly, to answer the whys, I think it is important to contextualize everybody here that the Azure Functions v4 is the latest version of the Node.js programming model for Azure Functions. And it comes with a bunch of new features, improvements. But it is extremely important to tell everyone here is still in preview. So the version 4 of the Node.js programming model is currently in public preview. Probably in the near future, probably will be as a general available. I was talking with some persons internally with the Azure Functions product team. And probably, I don't know if I can say something, but in the few weeks, probably will be a general available. But let's talk about some key changes, improvements about around to this v4 programming model. The first one is about the flexible folder structure. So the existing v3 model requires that each trigger be in its own directory with its own function.json file. I don't know if you used to use Azure Functions, but when you create a new function in the v3 model, you create a new function with a trigger name, with a HTTP trigger name, for example, and then automatically create a new folder with the name you included. And under this folder, we have two different files. Index, example, if you decide to use TypeScript language, so probably under this folder will have index.ts file and the function.json file. So this kind of the strict structure can make it hard to manage if an app has many triggers, for example. So the v4 model removes the strict directory structure and gives the developers the flexibility to organize triggers in a ways that make sense to their function app. So probably during the demonstration, I will be showing the difference between the oldest version and the actual version. All the improvement is you can define function in code. So the v4 model uses an app object as the entry point for registering functions instead of a function.json files. For example, to register HTTP trigger responding a GET request, you can call app.get method or app.http method, which was modeled after other Node.js frameworks like Express.js that also uses this object app.get method. So it's very concise. And then as the JavaScript developers used to use Express.js as a framework, so probably you'll be very easy to make this migration if you decided to do it. Other important thing to mention here is about trigger configuration, like methods and auth level that were specified in a function.json, because in the oldest version, you have to decide if you want to use the anonymous or which kind of the auth level you have to use in your function recently created. But right now, the code itself in v4. So it also sets several defaults for you, so which is why you don't see auth level, or output binding in the v4 example. Other thing is around to the new HTTP types. So I mean the v4 model, we've adjusted the Azure Functions product team adjusted the HTTP request and response types to be a subset of the fetch standard. The standard of type is unique to Azure functions. So in this case, they are using right now the Azure functions are using UDC package, which follows the fetch standard and is currently being integrated into Node.js core. And then now also we have a better IntelliSense. So the V4 model supports IntelliSense for JavaScript for the first time and improves on IntelliSense for TypeScript that already existed in the V3. There's some improvements also for durable functions. Like in the V3 model, you need to use the durable functions package in addition to add Azure/functions to write durable functions in the V4 model. Anyway, there's a lot of improvements, significant changes that can help the developers in migrating from the V3 program model to V4. But to summarize everything about it, I have pretty sure that it's so much easier to maintain and create API with this new version. Actually, not a new version of the Azure functions, but a new version of the programming model, okay? And talk is cheap, so it is the moment to show the code. So well, now comes the moment when we will demonstrate how to do this migration API that uses programming model from V3 to V4. So in this demonstration, we will migrate a singular function, listings. So this function is responsible for listing all the properties on the main page of the Contoso real estate application. My main intention here, want to focus on how to structure the project, because I'll be showing through recently the pull request that I made. But I recently wrote a blog post detailing step-by-step how to structure a project with a V4, or even I can show you by GIF how to structure in the first time using this V4 program model. So let me stop for a moment here. I don't know if you can see. Yes, you can see my screen right now. So this is the GIF that I told you right now. This is the way that you can structure the first time this new V4 programming module. So usually I'm using the Azure Functions extension. So I'm using Windows machine. So to activate it, so you have to use the command, I think, Control-Shift-P and type Azure Functions, 2 dots, and create a new project. So just only that. And of course, creating a new folder under the project to do this migration. After to create this first structure using the V4 programming model, it is the time to, let me see here, all the image that I have here. Just a moment. Also, you create in the first time using the V4 programming model, not in this image. Let me grab another one. Just a second. This one here. Okay. This is a Learn Live show, so nothing's recorded here. So probably we are going to commit some errors here, some mistakes. After to creating structure the first time the new V4 programming module, this is the new structure. See how easier you can read the functions. So you can see a source folder, functions folder, the local.settings.json file, the package.json, and tsconfig.json, because we are using TypeScript in this project. So you don't see anymore this here. If you want to, I think it's better to show the code. Let me show you the code. Let me share my code spaces here. I think is the moment. Let me restart the code spaces. Okay. Wow, there's a sound in. Okay. Still opening here. Just a moment. Let me. Okay, I think right now is finally good. Totally good. Okay. Here, under the packages folder, you will see two different folders. Okay. There's okay. There's the oldest using the v3 programming module, and a new one with API-v4. Now let's see some changes here. Once you create a new function using the v3 programming module, usually you type the name of the function. In this case, we are going to do this one here, the get listings. And see, before, once you create a new function in the oldest version, you will see two different files, the function.json and index.ts file. So inside of the function.json file, you have to decide which kind of the author level you have to use in this function, the route, the methods, all of the stuff related to this function. And then in the index.ts file, all the coding stuff related with this function. But with the new v4 programming model, once you create a new function, you will see this new structure here, as you can see. But inside of that, the Azure Functions extension will create in this source folder. And inside of this source folder, you will see the functions folder, and then all the functions created. So let's start to do some live coding stuff here. So I'm using here Azure Functions extension. So in this case, I'm going to use the command Control Shift P. Azure Functions, creating function, HTTP trigger. I'm going to call as listings, and voila. Also, you creating the first time is structured the project in the first time. Azure Functions will once you create a new functions, we create it under the new folder. So this is amazing to tell all of you here. I don't know if I have a time, but I think that I do this because we are running against the time right now. So probably I'll be, oops. There's a few informations here, but I'll do this way here. I'll be divide this screen here and then show a few changes between them. Because look, this is something very interesting to mention here. In the v4, in the left, we are using the v4. Okay, we are using the v4. And this side, we are going to use the v3. Okay. So let me grab this information here and this one too. Specifically, let me grab this guy here. Okay. So right now with this new v4 programming module, before you have to create two different functions. So look, we are using here a huge, this is a little project, but imagine application with the different models, with the different with the different classes. So probably this going to grow pretty faster. So it's hard to maintain this kind of project. But now with the API v4, you just only can see only one file. Inside of this file here, see, you can see the, there's only two methods here, the two functions here for get listing by ID and get listings. So this is the new way to let the code more concise, more easier to maintain. Okay. There's some changes here. For example, let me wrap this code here. Toggle reward wrap and wrap here too. Oops. Let me wrap in this side too. Okay. For example, let me grab, because this one is related with the listings. So we can see firstly related with the import. So we can see, where is the app here? Okay. This is all the important thing that I have to mention for all of you here, because right now you can create another, just to let more, applying the solid concept, you can separate the responsibilities. So you can create an index file and then import this app object, as I mentioned during the presentation, and then call all the functions that you created related with the functions that you want to run under this project. So let more organized the project, so everybody can see all the functions related with the project, not just only I want to see the for example, the route related with favorites. For example, in the oldest version, we have to go under the folder favorites and see the routes, and so a messy stuff. So right now you can organize this way, let it more very concise. That's why I decided to separate the files this way. Anyway, so there's it's not necessary to use the Azure functions and context HTTP requests. So the HTTP request is still the same, but right now we have HTTP response init and invocation context. The import, it is the same because part of this API we are using Azure Mongo API for Azure Cosmos DB and also Azure Database for Postgres. Here in the get listings, as you can see here, there's a different approach how you define the method. So it is the same as creating a Node.js or TypeScript function. So you have to export this function and call this function in different way, and using the request and context, it is the same as we can see in the Express.js. And then there's a part of the requests, so probably you can make some differentiations here. There's a part of very interesting here. For example, in this line here, specifically, let me check where it is. Probably here in the body. Yes, Natalia.
Yes, we are almost on time, Claudia. So I know you probably have still a few things to explain from the migration. We may invite everyone to go to your blog post, because you did a great job explaining all this and summarizing it in a blog post that is available for the community to go and read it. And we want to make sure that everyone knows that there are 2 more sessions. So Claudia, maybe since you're sharing your screen, we can... Oh, you're no longer sharing your screen?
Yeah.
Can you share back so we go to the wrap, please, and we let everyone know
the wrap. The wrap.
Yeah, let's wrap it up. And yes, we're going to ask our friend Justine in the backend to publish that link for everyone to follow and to go to that amazing blog post.
Can you see my
But
screen
we
right
want-
now?
Awesome. Yeah.
Okay, so
It's
let's wrap. Let me wrap here. So there's a few questions, but we don't have time, so probably we can talk about that later. But summarizing, we learn how what serverless APIs is. Now we understand why we should migrate from V3 to V4 program model, and finally a demonstration showing how to migrate a function. But mainly, we have lesson 3, the next session, unpack the backend integrations for micro-frontends. So you learn what authentication means and how it enforces route access, and learn a lot of all the stuff. You learn how to use Azure Cosmos DB, Azure PostgreSQL, Blob Storage, and CMS, how it works together, and see how authentication implemented in the portal. And finally, all of you will be ready to deliver our app into production. So probably Savannah Strawowski is a great girl. She's the AZD girl. So you learn how infrastructure as code makes deployment consistent. You learn how Playwright makes end-to-end testing automation reliable. And you learn how github-copilot can help author explain and refactor your code. So don't forget to register for the whole series. And finally, please, if you want to see the whole series, please use the link below, as you can see, below now in the screen. So use aka.ms/fall4ai, and everybody would be very welcome to see the whole series. Thank you, everybody.
Thank you.
Thank you. Bye-bye.
See you soon.